So basically you click a button and you get a bot 20 minutes later.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Today on How AI Happens, we're going to dig into another great example of where AI technologies can further enable humans to focus on their highest leverage activities. We're going to look into the technology powering chatbots. Chatbots combine a unique array of technologies, both natural language processing, live constructional models, and also enable experts to seamlessly capture and express their expertise in the form of an algorithm that can be utilized at scale. To dig into this, I sat down with the CEO of Mavenoid, a company whose AI powers hardware support in many forms, including the generation of fully customized chatbots at lightning speed.
Yeah, classic founder cliche story, PhD dropout, started a little company then that we later sold, worked at Palantir for some time, and then after that started Mavenoid, and here we are.
Got it. What was the PhD that you decided to walk away from?
It was in something called object recognition. So basically teaching computers to see and recognize objects.
It's funny, walking away from the PhD has come up a couple times on the show so far. I'm curious, what was it that made you decide to walk away from finishing the degree in object recognition and that you were better off starting your own company rather than finishing up in academia?
It was basically, I felt that the rate of learning wasn't as high as I was craving when I was doing my PhD. And PhDs, of course, by their nature, they are very specialized. Like you're kind of drilling down on one narrow subject. You know, when you look kind of back in history a little bit and you see kind of your heroes and you look at their PhD thesis, they were actually revolutionary for their fields. And then, you're kind of looking at the own thing, the thing you're doing yourself. And, you realize that probably like I'm not cut out for this. I crave much more action, much more speed of learning, and I wasn't getting that.
Who are some of your heroes whose PhDs you were reading?
One of my favorites of all time is Richard Feynman. If you could see my room here, you'd see that I have a picture of him in my background. John von Neumann, which is like a complete alien, not even, it's like as much similarity between him and a human as a human and a snail. So it's mostly people in science. I think one of the artists I really like is Leonardo da Vinci. A bit of a boring hero to have, but he was just smart in such a weird way, such a quirky way. Just very observant guy that kind of picked up every detail and was just very good at kind of finding unconventional solutions to problems.
I don't think that's a boring hero to have, particularly when you look at some of the sketches of the inventions you wanted to make. It's clear he was way ahead of his time. I like to think about what would he have come up with had he lived several hundred years in the future,
Yeah, he would definitely have done some good sci-fi novels, I think, if he was living now.
Definitely. Well, Shahan, I really want to learn more about Mavenoid. To set some context here, would you mind sharing a little bit about the company and the chief opportunity it is you are attacking? And then we can get into some of the heft of the technology as well.
Yeah, sure. So we're a platform for hardware support. So we let basically hardware companies provide amazing, just like very remarkable technical support of really any physical product. So devices, appliances, machines, stuff you can knock on with your hand. And the two main products that we offer on our platform are self-service. And we do that via kind of a smart product assistant that you can put in on your website or in your mobile app or any support channel you want. And then we also have kind of remote service tool, which we do through something we call live video support. This is basically the customer being able to just point their smartphone on a problem they have in their surrounding. It might be their microwave that has broken or something like that, and get kind of live help from an agent. So we work with companies like Jabra, HP, BSH, Logitech, all kinds of companies that are producing physical products. And we basically help them help their customers do things like setting up the product, using the product, troubleshooting it, all kinds of things that they might want to help their customers with. You also asked me about the problem that we're solving. The short version of that is that we're basically helping them to scale their hardware support, scale their tech support. And that's something which is very difficult to do for companies. They usually just throw more humans at that problem instead of trying to solve it with technology and automation.
Got it. And then when did it become apparent that utilizing AI for these tools was the right approach to solve this problem?
Yeah, it's certainly like if we could avoid using AI, we would avoid using it. It just happens to be our problem domain requires it. So in our case, there's actually many parts of the kind of target user experience that requires AI. So one example is users when they have a problem with a physical product, let's say they're the dishwasher at home, they want to be able to describe their problem with natural language. So they don't want just like multiple choice options when they're getting self-service. They actually want to express their problem freely, however they want. And you need to understand that language, which is obviously quote unquote AI. And then once you understand the problem, once you understand the intent, the question that the user has, you kind of want to go into a structured flow. Like you want to start to ask them specific questions to narrow down the problem, to troubleshoot the issue that they have, for example, if it's a technical issue. It's a hard problem to solve, to for example, fix something that's broken. But you also kind of need this thing to become better over time, for example. And then if we can't solve the problem, then we escalate it to a human. And that human actually, we wanted that human to be able to give feedback so that the bot improves. So for example, what solution did end up solving the problem? That's something that's very valuable and can kind of create an important feedback loop. Yeah, those are some ways in which we use AI. And then I guess maybe more interestingly, from an almost infrastructure level, I think one problem in general is that chatbots really suck. So it was actually an interesting question for us, like why do they suck so much? Like, is it really the best we can do? And one of the conclusions that we kind of came to there was that chatbots are very difficult to build, and not only build, but also to maintain, to update, to scale. Like, what do you do if you have built a chatbot for one product and you have hundreds of products? How do you add the next 99 products, for example? And it takes a long time to build a decent chatbot version one, even, right? And then they are not very robust. Like, if the world changes, it's actually hard to change the chatbot. So the other kind of more deep technical problem we're solving is building better bots, essentially.
What are some of the ways you manage to make these systems improve over time?
So we have a few ways that they improve over time. One is that we have, this kind of natural language understanding. That's the start of the user experience. The user, types in, or they can speak into the microphone or whatever, what their problem or question or issue is, and we try to guess their intent. Essentially, like, what does this person want to ask? What is their problem? And that's something that is very important for it, A, to become better over time, and kind of B, not to suck when you launch it. Because people, it's customer facing, so you lose a lot of trust with your users, and our customers wouldn't launch it in the first place if it wasn't had a very high quality from day one. And then the other thing is, once you know what the issue is, you go into trying to solve that issue, resolve it in some way. Whatever that path is that the user goes through, you want to improve that path over time, optimize it, and make it better. Finally, you want to be able to build bots very quickly and very smoothly. You don't want to invest a lot of time into doing so. So you can say the most magical feature that we have is auto generation of bots. So basically you click a button and you get a bot 20 minutes later. And then you can edit that bot and improve it, add images, change the logic of it a little bit if you find it lacking in some areas. And once you built it, the way that we help our customers to maintain it is to suggest things dynamically. So while they're looking at all of this content, while they're looking at the bot, this is kind of a big canvas in our user interface. While they're looking at this canvas, they can kind of not just paint themselves on the canvas, but they also get suggestions for the next brush strokes.
How does it know what to suggest? Is there like a base level kind of model that it builds off of? How does it know where to point the user?
We took a few different approaches to this problem. Basically, the current approach we take is that we basically scrape a lot of different data sources. Like we scrape information from the internet, we find information about problems, solutions, issues that people have in forums and places like that. A lot of various public data sources. Wikipedia, for example, we use as well. And then we also use private data sources, you can say, like things that only the company has, like their own support ticket data, manuals that might only be used by internal experts, that's not publicly available, and things like that. And then it's kind of a linguistic approach. So given the kind of nodes that we have in our model, and by nodes I mean things like symptoms, solutions, and stuff like that, we kind of guess what a reasonable connection to that node would be.
Got it. So this is kind of leading to this the natural language processing that's at play here, and so I'm curious how you were able to sort of develop your NLP approach within the parlance of hardware troubleshooting. Very different than how you and I speak to each other, how regular sort of automated speech recognition happens, how regular sort of conversational AI takes place, I imagine.
I guess we had two main problems that we're trying to solve. One was, you can call it semantic matching. Basically, our issue was that, our users would on the one hand use kind of super vague terms, right? They would say, for example, there's something wrong with my swirler, right? And what they mean is there's something wrong with my fan, for example. Like, they can use lots, and you can even use like swirls with a Z, or like that's a bad example, but people would kind of, they can be very vague in how they express words and problems and concepts.
My aunt calls a garbage disposal the garburator.
I love that.
Yeah, so you would need to have garburator in your parlance.
I mean, if we collected the crazy stuff, I mean, people say X thingy for stuff. Like if we just collected the kind of amount of crazy stuff that we've seen, it's just like we have like 100 examples per day. It's pretty crazy how imaginative people are. But the interesting thing is, on the one hand, they can be very vague people, right? On the other hand, in our domain, they can be also highly technical, right? So they have an issue with their dishwasher, and there's like an error code on the display of the dishwasher, right? And they will say, "Hey, I have E109 error." And it says that, the power is low or whatever. So they can be very technical and very vague at the same time. So that's like one thing that we have to solve in a way that other type of support doesn't have to solve. Like that combination of like vagueness and being highly technical and highly specific about the hardware problems they have. And then the other, maybe even bigger problem we had is kind of, turns out that expert time is very limited, right? So we actually have very, very precious and very little time from people who actually know the products. They're very busy. Like they don't have time sitting for like they do in big chatbot projects. They don't have time sitting for weeks just building a chatbot. They have a job to do. So what do we do with like 100 times less expert time than what's reasonably used in chatbots? This is one of the big reasons why chatbots fail, actually. Our approach to that is pretty simple. So on the kind of semantic matching side, we use pretty standard modern methods, but very much tailored to our domain. So for example, transformers in particular has made kind of this problem much easier for us compared to when we started the company. For example, we recently adapted the GPT-3 to our domain, which is really cool. We're kind of constantly changing these methods, but in the beginning, when we used kind of word embedding and kind of standard, more old school approaches, this was actually quite tricky. It was something we had to push through the friction to actually get somewhere with. And then I think the other piece, how to use human time effectively, basically a smorgasbord of things we do to that. I'll give you just a few quick examples. So for example, we let experts just enter their intents and then have the system kind of understand immediately what they mean. They don't have to give a lot of examples of, these are the different words that people can use. These are the different terms they can use. They can just say one time what they intend, and that's enough. Kind of like one-shot learning, I think, is the buzz term for that. The other thing is that we, like I already mentioned, we can auto-generate models. Basically, the philosophy there is that we try to build, a model that's 70% of the way to a good model, but we do it with 30 seconds of the user's time instead of 30 days. So it's not quite there. They still have to like build it out, but it's very important to start to build momentum in that human's brain that like, hey, this is actually very easy and fun. I can start building this bot. And similarly, once they built it, we want to keep that momentum going. So we do things like auto suggestion, right? We help them guess other nodes that they could put on our graph, for example. This is the way in which we build the bots. So it's all kind of tailored towards, we have a few minutes, a few hours of this person's time. Initially, only a few minutes, right? They might get bored. How do we win them over immediately? How do we make them think that this is like unlike any other chatbot project before, if they have seen other chatbot projects, or how is this just a fun way for them to enter the knowledge into the system?
So how do you do that? How do you make them excited about engaging with it?
Actually, like the auto generation is pretty fun. Like you enter your product's name and a URL where the product is described, and you click a button, and then you get an email 20 minutes later saying, "Hey, your model is ready. Do you want to give it a spin?" And that's usually blows people's minds. Funnily enough, some people, they are not impressed at all about that because they don't have any expectations. They've never tried to build a bot before. But the thing that impresses those people who are kind of the more cynical version of the crowd is when they kind of get suggestions and they haven't thought about the suggestions themselves. I think one great way to impress people is to surprise them and then make the surprise seem intuitive and kind of seem to make sense to them immediately. And of course, the reverse of that, which is also something we've seen, is if you surprise someone and they don't like your suggestion, even if you're correct, they might burn you at the stake. So it's something that we actually constantly have to balance.
Why might someone not like the suggestion even if it's correct?
I'm an expert. I've been doing this for 20 years. This system is to just,
got it.
Yeah. So that's kind of a very human thing to kind of rebel against.
Is there anything you can do about that? Like if someone is just too proud to take the advice from a robot, from a chatbot?
I think that's a really interesting question. I think one way is to explain to them how you arrived at your suggestion. So for example, if you have a complete black box method and you just say, just trust me, that's not as helpful as saying, look, here's the logic laid out on a canvas in a pedagogical way. This is why we think you should do this.
So I like that you refer to this, the area where these models are generated as a canvas. And it sounds like in the case where you can kind of show exactly why it's suggesting what it is, that it's displaying these sort of attention mechanisms. Is that what's kind of at play here? Are you sort of letting people click into why it believes what it believes?
Yeah, so it's very easy to immediately see. And our system, by the way, it's not like a simple flowchart or a decision tree. We have our own kind of way to lay out that logic. But it's basically as simple as a decision tree. It's just something that people haven't seen before. We call it check flows. And you can basically see how is the system thinking, for example, about what symptoms lead to what other symptoms. So symptom might be, smoke is coming out of a hole. And then, that might lead to, actually, that might be caused by overheating of some part of a product, for example. So then you can very easily see how those two symptoms are connected on a graph in a very visual, it's almost like a visual programming language. Like you can kind of, code a chatbot without being a programmer, right? I think the buzzword for this is no code or whatever people call it nowadays. But that's very important if you're going to have a system that gives technical advice to people at homes, right? You don't want somebody to just electrocute themselves, or you actually have to have reviewability of the stuff that you're publishing.
And the no code approach, the like enabling non-technical people to really develop exceptionally technical sorts of materials, it speaks to this change I'm sort of observing in the human in the loop metaphor, I guess, or even just the visual of a human in the loop. And it's less about like the human in the loop as a babysitter, as a chaperone, and more about it working in parallel. Is that kind of how you see how your technology pairs with the user? How do you compare it to the traditional sort of conceptions of human in the loop technology?
Yeah, that's a good question. So I guess the way we view human in the loop as a metaphor is very, very dehumanizing. We like to think about it as amplified intelligence. Like, how do you amplify human intelligence? So it's basically kind of the Iron Man model instead of the Robocop model, right? So, Iron Man, he steps into his suit, right? And he only does so temporarily. He's not always in his suit. And he, gets useful advice from his suit. Like Jarvis kind of says some gives him some tips, and he can take those advice to heart or not. And, whereas the kind of other model is you're kind of this rat in a cage. You're barely aware that there is a machine there, and you're kind of just kind of doing simpler tasks. You're basically more a machine than a human. You're more machine than a machine almost. The way that we approach this, I guess there's a few different ways. One is that we kind of want to minimize the time the human spends in the loop, right? We want them to just visit the loop, like have a vacation in the loop, not be in the loop all the time. So it's like you touch the loop, you give the system some advice, and then you jump out of the loop and you do your human things. And we do that, for example, to be a bit more concrete. We kind of, for example, for experts, we provide them a very carefully prioritized list of suggestions that they can take or not take. Basically, changes in the logic of the bot that they can accept or not accept, and we aggregate. Kind of all of the cases that are coming in from real usage of the system in a very nice way. So like they can, for example, see that 20 users, 20 cases indicates that you should make this change, and this is third in their priority list, right? So then they can even look through those cases and kind of make their own. They can dive deeper if they want to see why we're making that suggestion. Then I think it's also a very important part actually that we underestimated in the beginning was putting the right people in the kind of the right loop, right? So there's many different loops. For example, if you are a beginner and you're not like a super expert, you're just a support agent that started a few weeks ago, maybe then it's fine that you kind of just correct some misunderstandings in the English language, or you give some simple feedback. Whereas if you are a very knowledgeable expert, you really should only be asked for things that require your expertise. And that's something that has been a very important part of our design philosophy. The other thing that actually is quite interesting is how do you make the loop frictionless in some sense, right? How do you make it fun for the human? So one way to make it fun is that you learn by being in the loop, right? So you're actually we talked before about being surprised, right? So you actually stretch your abilities, you get suggestions you haven't thought about. You give feedback for products that are adjacent to the product you're expert in. Things like that is something we're thinking a lot about as well.
Yeah, and it all seems in service of you making it frictionless. Also, how often do you ping the technical expert? It's all in service of enabling humans to do their highest leverage activity, right? And so in these cases where it's like, okay, we don't need the expert to do X, we need them to do Y. Like you sort of are able to be more efficient in like this whole goal of not replacing work, but replacing the boring work, replacing the menial tasks to allow people to really flex their particular expertise in a high leverage way. Seems to be just kind of an overall goal, kind of across the industry, really.
Yeah, no, that's very important for us. But I think it's particularly important in domains such as ours, where the work is extremely repetitive by its nature, right? So hardware products, you can't update them just magically, right? So if you have an issue, the same issue is going to come back like crazy. Like it's going to be very, very repetitive. So I think in those situations, it's particularly important to not just view humans as kind of literal cogs in the wheel.
Yes. Yep. Exactly. Well, Shahan, this has been fascinating listening to you. Before I let you go, I would quickly love to ask you one more thing. What is most exciting about our field, about AI and this technology? Like if you ever lay awake at night just kind of being curious and excited about this technology, as I'm sure you are, what are some of the applications and the uses that you're excited to see play out?
I think for AI in general, I guess it ties into a little bit with the purpose of our company as well, but it's basically like how can AI help us to make hard things easy? Like how can it make hard things? Like I think that's a kind of a theme that I'm very fascinated about. So for example, there are a lot of complex problems we have to deal with as humans, but you can break them down into simple steps. And AI is great at breaking things down for us, right? And it should break things down for us where we're not that interested in solving those problems because they are repetitive or they're not very interesting. They have been solved by other people before. So, for example, whenever you step up to a piece of technology and you have a question about it, or you scratch your head, it can be, for example, my grandma doesn't understand a remote control. Literally, like after 20 years, it's the same remote control. She doesn't understand it. When she steps up to that remote control, like it should be very easy for her to immediately understand how to use it. She should be able to just ask any question from it. She should be able to do what she wants to do with her television without having to figure things out. And I think that's the purpose of Mavenoid, to make technology more easy for people. But I think that's true in general. Like we should have everyone should have their own little assistant, giving them advice about things to make their lives easier and more fun.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.